In last lecture, we have seen that rules of tracing the curves. Now we will see an example of tracing the curves. First, this is y square into bracket a plus x equal to x square into bracket 3a minus x. We have discussed the first point of tracing the symmetry is tracing the curve is symmetry. From the equation you can see that there is a y square term, there is only term of even term. Here it is x square, but x into x square gives you x cube. Therefore, there is only symmetry about x axis. Symmetry about x axis. Curve is symmetry about x axis. Next thing is origin. There is no another symmetry. You can just by observation you can say that the curve is not symmetric about y axis. Even it is not symmetric about oblique asymptotes, etc. Now what is about origin? As there is no constant term, curve passes through origin. Curve passes through origin. Third point is tangent at origin. Tangent at O. For that, what we have tried? We have tried equation as ax square plus xy square equal to 3ax square minus xy square. Now equate the lowest degree terms to 0. What are the lowest degree terms? Its power is 2, its power is 3, its power is 2, and its power is 3. And therefore, you may write ay square is equal to 3ax square. That is y equal to plus or minus 3x. There are two different tangents at origin, and therefore origin is a node. That is y equal to 3x, root 3x and y equal to minus root 3x are tangents at origin. And therefore origin is node. Fourth point is whether curve has x-intercept and y-intercept. Substitute intercepts. First thing is substitute y equal to 0. That implies x square into 3a minus x equal to 0. That is x equal to 0 or x equal to 3. That is 0, 0, 0 and 3a 0. Are x-intercepts. Zero, 0 and 3a 0 are in x-intercepts. On the same line, we will find y-intercepts. On the same line, we will find y-intercepts. For that, substitute x equal to 0. If we substitute x equal to 0, we get y square equal to 0. That is 0, 0. Origin only. Which we have mentioned as a origin as a point. That means Now next thing, now we have to find asymptotes, whether that curve has asymptote or not. For that, what we can do, to find out asymptote parallel to axis. Curve is symmetric about x-axis, therefore find asymptote parallel to axis. For that, you can write y square equal to x square into bracket 3a minus x divided by a plus x. And you can see that for a plus x equal to 0, y tends to infinity. That is, x equal to minus a is asymptote. X equal to minus a is asymptote here. Now, as a sixth point, you can find the region. What happens from this also? Y square is negative if x is less than minus a. If it is written, this point is this term is negative when x is less than minus a, what happens here? Again, y square is negative if suppose x is positive, but if it is x is greater than 3a, what happens? If x is greater than 3a, this bracket will become negative, and then y square is negative if x is greater than 3a. That means that is curve lies between x equal to minus a to 3a, and this is the region where the curve lies. Now we'll see what will be the nature of the curve. For that, you may make use of the table as for x equal to minus a 0, a 2a and 3a. What is value of y equal to? You are familiar here. At x equal to 3a, y is 0. Now you can write y square equal to x square into bracket 3a minus x upon a plus x. Even at this point also, at this point it becomes infinite. What happens if x equal to a? Y square equal to a square into 2a divided by 2a. 2a get cancelled. Y is equal to plus or minus a. What happens at y is equal to 2a? Y square equal to 4a square into bracket a divided by 3. That is, y is equal to plus or minus 2a by root 3. Plus or minus 2a by root 3. Now we will find the nature of the. Now how it is? Suppose this is the origin minus a, 2a and 3a. You can see that curve passes through origin, curve is node. Next thing, this is asymptote. X equal to minus a is asymptote. Curve is symmetric about x-axis. Here, tangents are, two tangents are there. Y equal to root 3x, y equal to minus root 3x. Next thing, tangent at this position, actually this tangent we are also calculated by using dy by dx also. These are the tangents and asymptotes. What happens, as it is node, curve will be like this here. At this point, curve will be like this. And for x equal to a y is plus or minus a, this distance. At x equal to 2a, y is here, somewhere here. And this is the curve. Thank you. We'll see next problem in next video.